Okay, let's see now an example of interactions. So we have two explanatory variables, and we construct the data like that there is an interaction between one and the other explanatory variables. So let's suppose that we have two variables, the females, the gender, and being sick or not. So regarding the gender, we have two levels, female and male, and regarding the condition, we have two levels, healthy and sick. So I'm going to construct a data matrix of expression values composed of 1000 genes and 100 individuals. Now 1000 genes, 100 individuals, this means that the total matrix should be 1000 by 100. The first 25 individuals are healthy females and their expression values is about 100. The next 25 individuals are healthy males and their expression value is around 120. So here being a male in the healthy condition, we have a plus 20 between females and males. Now in the sick condition, the females have a value around 120 and the males have a value around 100, which means that being a male, you have a minus 20 effect. Now this means that we have, for all these 1000 genes, an interaction between being healthy and being female or male. So between the gender and the condition, we have an interaction. So I construct here the matrix. This is the dimensions of the matrix, 1000 rows, 100 columns. I construct the labels. And let's see how this will work for one gene. So let's take the first gene, first row of the matrix. We're going to model it using the health multiplied by the gender, and the p-value for everything, for all the variables, the health, the gender, and the interaction is statistically significant, of course. Now, what I'm going to show here is how to do that for all genes, all the genes. So this is for the first gene, which means that, okay, let's write a for loop and store the values here. So what should be the length of the vector that will store the p-values? Since we want one value per row, it means that the number of p-values that we will have will be as many as the number of rows of the matrix M. So p-values will be a vector of mode numeric, so it will store numeric values, and the length will be the same as the rows of the matrix M. So by default, this is the vector p-values. Okay, the simplest is to write a for loop. That the length of the for loop will be as many as the number of rows of the matrix M, and for every row we will apply such a model. Here I need to get the summary of the model. So my summary, let's say my summary will be summary of my LM. And if we go back here and we get the summary for the first row, we see that we get the matrix of the coefficients here, and the p-value is the fourth column, 1, 2, 3, 4. So these are the row names, the table names, the row names of the table. First column, second column, third column, fourth column. Okay, let's see that in more detail. So to get the matrix of the coefficients, I must get, I can do it like that. So this is a summary. It's actually a complex construction. It has several things. I can see these several things by using the names. And one of the things that it has is these coefficients here, down here. Okay, so if I want to get just the coefficients, which is this table, I must write here coefficients. And I just got now the table. And if I want the p-value, for example, for the effect of the health being healthy or not, so here I must get from coefficients the second row and the fourth column. Second row, this is the first row, this is the second row, and the fourth column will be this value. So this is the p-value for the effect of being healthy, of being sick, for the gender 0, and the gender 0 is the female. Okay, so the effect of being healthy in the females. This 1.14, this 1.14, this value here. You see that here. Okay, if I'm interested in this p-value, so if I just want to get the genes where the effect of being sick is statistically significant for the females, I must get this value here. Okay, so this is pretty easy now because I can get all this line and put this line here. And instead of writing summary my LM, I can write here my summary. And this will be in the p-values in the position line. Of course, we have constructed the data like that everything is significant. So the p-value should be actually small. You see the numbers here. And even if I will apply some correction, adjust this is a correct function. Now it's called adjust the p-values, and the method should be the Benjamin-Hochberg, the FTR, so corrected p-values, this one, so the corrected p-values are these ones, and all of them again seem to be significant, or at least you know most of the values are pretty small. Okay, so this is how we can get the effect of being sick, at least for the females, which is the reference level.